Question 1. Tell us your name and tell us about your project.
Hi, my name is Sijin Tang. You can call me Teresa. Today I am going to talk about solar eclipse observation project led by my colleague Sir Arthur Eddington. Sir Arthur Eddington is the Secretary of Royal Astronomical Society. On May 29, 1919, Sir Arthur Eddington and I and a group of astronomers went to Island of Principles off the west coast of Africa to watch the eclipse for the purpose of testing Einstein's theory of general relativity. Since the masses of celestial bodies would cause space-time to curve, the scientists wanted to find out how much the light would bend. Eddington took nighttime baseline measurements of the positions of the star in the Hyatt cluster in January and February of 1919. These pictures would be compared to the measurements taken during the time of the eclipse, because during the eclipse, the sun would cross a cluster so the starlight could be visible.
Question 2. What were you guys trying to do or find?
Because it was during World War I and Einstein is German, his general theory of relativity, which was proposed 4 years earlier, was not taken seriously. Einstein proposed that the space was combined with another dimension time, which creates spacetime. Objects that travel through spacetime will be warped, bent, and twisted by the masses and motions of objects within spacetime. However, Isaac Newton had a similar prediction that light would bend in gravitational field, but only half as much as what Einstein predicted in his theory. We were trying to convert Einstein's theory of general relativity as the purpose of the trip and figuring out if Einstein is more accurate comparing to Newton. The eclipse was a perfect time to test the predictions because the moon was blocked by the sun and the light would bend or curve around the moon. By comparing and analyzing the baseline measurements of the star's position during regular time with the measurements taken during eclipse, our team found that the measurements were within 2 standard deviations of Einstein's prediction. However, it was 4 standard deviations of Newton's prediction. We were able to prove that Einstein's general principle of relativity was correct.
Question 3. Where did the project or experiment occur?
We had 2 teams performing the experiment. My team with Eddington went to Island of Principle, which was in the Gulf of Guinea off west coast of Africa. The other team was formed by a group of astronomers who went to Sobral, Brazil. The purpose of the second team was to make sure the experiment could be running properly in case the eclipse was blocked by clouds over Principle. Luckily, both locations had clear skies during the time of the eclipse. However, both teams met a few obstacles before they were able to take the measurements. Our team's location was in heavy rain and clouds before the eclipse. The Brazilian team's large telescopes were warped by tropical heat. They were forced to use a similar 10-centimeter instrument as backup. After the solar eclipse, both teams went back to England to analyze the data just collected.
Question 4. What other significant events were happening around the world at that time?
There were a lot of things going on during the time of the experiment. At the time of preparing for the experiment, World War I was raging. All the factories and industries were focused on countries' military needs, so it was hard for Eddington to get required astronomical instruments. The war ended in November 1918 and the team pulled together and prepared for the experiment, which occurred 5 months later. The Treaty of Versailles was signed on June 28, 1919, was the most important peace treaty that officially ended World War I. Other important things happened during this time period was the forming of League of Nations in 1920. It is an international organization in the purpose of preventing war and settling dispute between countries. In 1919, Benito Mussolini established the Italian National Fascist Party. Also, a few years later, in 1922, astronomers at Lake Observation in California repeated the experiment that got similar results. As a woman, I am more interested in a few important events happening for women to get equality. In 1918, UK women gained limited voting rights, and in 1919, the 19th Amendment was passed guaranteed women in US the right to vote.
Question 5. Who else was involved in the project?
My friend Sir Frank Watson Dyson, who was Astronomer Royal of Britain, was the first person conceiving this experiment. He suggested to plot the positions of background stars close to the sun's limb during the eclipse. By comparing the position of the stars during the eclipse and their normal positions, we could test the effect of space-time warping. In this way, we are able to compare Einstein's theory with Newton's theory. Besides Sir Arthur Eddington and I, who went to Island of Principle, Andrew Carmela and Charles Davison also involved in the project by leading the second team of astronomers to Sabro, Brazil.
Question 6. What was your role in the project?
So I traveled with Sir Arthur Eddington to the Island of Principle to assist him collecting measurements of stars' position during eclipse. I helped with calculating and analyzing the data collecting from both positions to determine how much the light bended. The result of the experiment helped to confirm Einstein's theory of general relativity.
Question 7. What impact did your project have on the physics community?
The project, the experiment also showed that light could bend around massive objects about twice more than Newton's prediction, and the experiment result confirmed Einstein's prediction. Our project has a huge impact on the physics community because the experiment proved that Einstein's theory of general relativity is correct. It made Einstein famous worldwide. As a German physicist, his work finally got considered by the science community. At first, not everyone immediately accepted the experiment result. Some even accused Eddington of manipulating his data. However, after repeating the measurements during 1922, 1953, and 1973 eclipse, the result got more accurate over time and finally accepted by most of the physicists by 1960s.
Question 8. What obstacles did your team meet? How did the finding influence and give support to astronomy later?
As I explained in the previous question, both the Island of Principle team and the Sabro Brazil team face a lot of obstacles. Our team at Island of Principle faced bad weather consisted with heavy rains and clouds over the day of the eclipse. Luckily, we were able to take a few pictures of the eclipse as the sky cleared by the time of the event. The Sabro Brazil team had some problems with their data collecting journey as well. The large telescope they had was warped by the tropical weather, and they were forced to use the backup small instrument. The finding was important for astrophysics later in the years, and the bending of light around massive objects, which is known as gravitational lensing, was an important tool for physicists to use in order to understand dark matter and the expansion of the universe. Thank you.